Okay, so we were discussing ionization energy in the last class, and I told you that ionization energy is always an endothermic process. Okay, and then I told you the factors on which the ionization energy depends. Okay, I told you that ionization energy depends on the size of atom and also the charge and also the shielding effect. Okay, we have multiple factors of ionization energy. So then I was telling you that successive ionization energies, regarding the successive ionization energies. You know what is successive ionization energy? Successive ionization energy. Successive. Successive ionization energy means that if you have this element, let's suppose we have magnesium and this is in gaseous state, you are going to provide energy, obviously, then it would be removing its outer electron, then it would be forming what? Mg positive ion. Okay, it would be forming what? Mg positive ion. This is called the first ionization energy. This is called the first ionization energy. Okay, but as you know that magnesium is in group 2, so magnesium has an ability to lose 2 electrons. In fact, magnesium has an ability to lose 2 electrons. Okay, magnesium has an ability to lose 2 electrons. So when you have removed first electron from the outer shell of a magnesium atom, so then it would be having +1 charge. It would be having +1 charge. Okay, so then obviously I can also remove its second electron. Okay, then I would be writing this ion, and then again I would be providing energy, and then this would be removing second electron. This is called the second ionization energy. This is called the second ionization energy. This is called the successive ionization energy. Okay, so the thing is that if we are going to remove more than one electron, so the ionization energy is going to increase. So the ionization energy is going to increase. Let me show you the data booklet. Let me show you the data booklet in which you would see a lot of ionization energies. As you can see, as you can check over here, the successive ionization energies, just like that. Samir, can you please mute your mic? Yes, can you check it? Magnesium, whose proton number is 12. Can you check it? Magnesium, the first ionization energy is 736 kilojoules per mole, and the second ionization energy is 1450 kilojoules per mole. As you can see, the second ionization energy is almost doubled. As you can see, the second ionization energy is almost doubled. Why? Why the ionization energy is doubled? Why we are supposed to give more energy to remove second electron? This is the main theme that we are going to discuss right now. Okay, so I would be telling you that as we are going to remove more electrons, so it would be more difficult to remove electron. It would be more difficult to remove electron. Okay, same goes with aluminum. Same goes with aluminum. First of all, you would be removing one electron from the outer shell of aluminum. It would be forming positive ion, just like that. This would be called first ionization energy. Okay. Then I would be removing its second electron, just like that. Then I would be removing second electron. Okay. It would be having positive 2 ion. It would be forming positive 2 ion, just like that. This would be called second ionization energy, and then I would be removing its third electron. Then I would be removing its third electron. Okay, and then it would be forming 3 plus ion, and this would be the third ionization energy, and this would be the third ionization energy. Okay, so so let's check the ionization energies of aluminum. As you can see, the proton number is 13. The first ionization energy is 577. Okay, and then the second ionization energy is 1820. Okay, and the third ionization energy is and the third ionization energy is 2740. Okay, so as we are going to remove more and more electrons, so the energy is going to increase that we would be providing basically. Okay, so it's going to be difficult, basically, I want to say that. So the question is why. Can you tell me, anyone know, like, why the ionization energy is going to increase? Yes, can anyone tell me, please? Yes. Subhan, Tala, Hadia, Ahmad,
Because as we go
Iman.
further away from the nucleus, so it's harder to like it requires more energy.
When we are going further from the nucleus, so it's mean that the attraction is going to decrease. So it is supposed to be easier to remove electron, but in fact, in reality, it's going to be difficult to remove more electrons. So
Yes.
you are telling me the opposite thing. You are saying that it's going further away from the nucleus. So then why the ionization energy is going to increase? It should be decreased if this is going further away from the nucleus. Yes, Hadia Muzaffar. Can you tell me, Hadia Muzaffar? It's very easy. Yes, Hadia.
I'm not sure.
No.
Is it because the group number is changing?
Okay. Let me tell you. Let me tell you. Let's suppose this is magnesium. Let's suppose this is what? Magnesium, in which it has 12 protons in its nucleus. Okay. It has 12 protons in its nucleus. Okay. Then in the first shell, it has 2 electrons. Then I would be making its second shell, in which it has 8 electrons, just like that. And then I would be making the third shell, in which you can see 2 electrons in its outer shell. Okay. Then I am going to provide energy to this magnesium. Ultimately, it's going to remove its electron, just like that. Okay. It's going to remove its one electron. Okay. Then I'm not supposed to write one electron. Okay. It has removed its one electron, and now it has a positive charge. Now it has a positive charge. Can you tell me what is shielding? Can you tell me what is shielding? Yes.
Sir, it's
Yes.
when the inner electrons shield the outer electrons from the protons.
Exactly. Basically, the shielding is the repulsion between electrons. Basically, the shielding is repulsion between electrons. Okay. Repulsion means that, let me zoom in. So as you can see, this is having a positive charge. Okay. And outer electrons are attracted towards the nucleus due to the oppositely charged ions. As you know that opposite charges attract each other, and these are electrons having a negative charge. So when they are going to show attraction towards the nucleus, but the thing is that these are the electrons also having a negative charge, so they would be repelling outer electrons. This is called the shielding effect. This is called the shielding effect. They would be repelling each other, just like that, just like that, just like that. They would be repelling just like that. Okay. So basically, there is a repulsion between electrons. So when there is a maximum repulsion between electrons, obviously these electrons can be removed easily, because you know that uh, they are going to show attraction towards the nucleus, but here are a lot of electrons between outer electrons and the nucleus. These are called inner electrons. So they are causing shielding. They cause shielding basically. They cause resistance. What type of resistance they are going to have? So basically, they are going to interrupt the force of attraction between the outer electrons and the nucleus. As you have more inner electrons, so means that you have more shielding. When you have more shielding, it means that the outer electron would be having a lower attraction towards the nucleus. So you can remove easily. But right now, I have this versus this. We have two structures. We have to decide in which structure we have more shielding. In which structure we have more shielding. As you know that in this structure we have more electrons. We have more electrons. Okay, it's mean that we have more shielding. More electron means more shielding. More electron means more shielding. Okay, less electrons means less shielding. Simple. More electron means more shielding. Less electron means less shielding. So in which I have less shielding, in this I have more shielding. So when I have less shielding, as you know, the electrons are going to decrease. Electron is removed basically from the outer shell of a magnesium atom. So what does it mean? Shielding decreases. What does it mean? Shielding decreases. So I am supposed to write over here more electrons, more shielding. Less electrons, less shielding. Okay. So why when the shielding is going to decrease, so the attraction is going to increase. Remember, when the shielding is going to decrease, so the attraction is going to increase. As you know that, for the simplicity, I'm going to remove inner shells because they are the same. Two inner shells. The number of inner shells are same. Okay, the number of inner shells are same. Okay, so as you know that the proton and electron, okay, so 12 protons and 2 electrons, 12 protons and 2 electrons, right? And in that structure I have 12 protons and 1 electron. 12 protons and 1 electron. Okay, 12 proton and 1 electron. So what does it mean? It's mean that they are having more repulsion. They are having more repulsion. When there is a more repulsion, so there would be a less attraction. Here we have less repulsion, so it's mean that we have more attraction. So the size is going to decrease. Why? The outer electron is going towards is having attraction towards the nucleus. So when the size is going to decrease, ultimately you can say that it would be difficult to remove electron. Ultimately you can say that it would be difficult to remove electron. Why? Because the size is going to decrease. So I can say that it has a less size. Okay, so more attraction. So when there is a more attraction, what does it mean? It would be difficult to remove electron. This is the reason we can say that when you are going to remove more than one electron, so it would be difficult to remove electron. It would be requiring more energy. Due to this that I have told you. Like the shielding effect also matters a lot. Also the size. Yes, Iman?
Less size of what?
Size of atom is going to decrease. Because there is having a less repulsion. When the electrons are going to have a less repulsion, so automatically they would not be pushing each other. Obviously they would not be pushing each other, when the electrons are going to push each other, so as a result of this the size is going to increase. So in this the shielding is less. Obviously the electrons are not going to push each other, so the size is not, so the size is not larger. It's smaller due to the less repulsion. And when the size is smaller, so ultimately the outer electron is closer to the nucleus, so having a strong attraction. So therefore, you would be providing more energy as compared to this one to remove this electron. Okay.
Okay, sir.
Yes. So always remember, whenever you are going to remove more than one electron, so always you would be giving more energy as compared to the previous one. So the successive ionization energy always increases. So the successive ionization energy always increases, remember. Sometime examiner would be asking why the second ionization energy is greater than that of first. Why the second ionization energy is greater than the first. So then you would be writing the reason. Okay. Why the second ionization energy of magnesium is greater than the first ionization energy. You are supposed to write it down. I'm going to give you 1 minute, but fast. You're supposed to write it down and then send me, then I would check. To discuss, after discussing this, we have to discuss the trends. We have to discuss the trends. Okay. When we are going down the group, basically there are two types of trends that we would be discussing. We have two types of trend that we would be discussing. Number one, we have group trend. Number one, we have group trend, and then we have periodic trend. Group trend, and then we have periodic trend, right? So can you tell me, if we are going down the group, so the ionization energy is going to increase or decrease, like periodic trend and group trend? So first of all, we are going to discuss the group trend. As we go down the group, so the ionization energy is going to increase or decrease. What do you think? Yes?
Decrease.
Why? Why decrease?
Due to the increased shielding effect.
First of all, tell me the size, because the size is inversely proportional to the ionization energy. Always remember, when you are going to discuss the ionization energy, so you must know the size. As the size is as the radius, or you can say the size is inversely proportional to the ionization energy. Inversely proportional to the ionization energy. Okay. So as we go down the group, as we go down the group, so the number of shell increase. As we go down the group, so the number of shell increases. When the number of shell increases, it's mean that the shielding is going to increase. The shielding is going to increase. As you know that in lithium, the proton number is 3. When you would be drawing the electronic structure of lithium, so you would be drawing only 2 shells. And if you are going to draw the structure for sodium, so then you would be drawing 3 shells. And if you are going to draw the structure for you can say potassium, so you would be drawing 4 shells. As you know that when the number of shells are going to increase, so it's mean that the shielding is going to increase. Shielding is basically the repulsion effect between the electrons. So it increases by the increase in the number of shells. So let's suppose, let me explain it. This is lithium who has 2 electrons in the first shell, and then we have 1 electron in the second shell. This is lithium. Okay, this is lithium, and same goes with the sodium. But as you know that the sodium is having a proton number that is equal to 11, so I would be writing more electrons just like that. This is 8, this is 8, and then I would be drawing 1 electron. As you know that 2 inner shells. How many inner shells? 2 inner shells. What are inner shells? The shells between the outer electron and the nucleus. What are inner shells? The shells between the nucleus and outer electron. This is called the inner shell. And in this we have only 1 inner shell. In this only we have 1 inner shell. We have only 1 inner shell. So as the inner shell increases, so the electrons would be repelling each other badly. They would be repelling each other badly. Ultimately, when the electrons are going to repel each other, as a result of this, they would be pushing each other. In fact, they would be pushing each other. As a result of this, the atomic size is going to increase. Okay. So when the atomic size is going to increase, so the ionization energy is going to decrease. So the ionization energy is going to decrease due to the increase in atomic size. So this is the relation between the size. This is the relation between the size and the ionization energy. Okay. Then we have group trend. Then we have periodic trend. Okay, periodic trend. Generally, we talk about, you can say, the period 3. Generally, we talk about the period 3, right? Generally, we talk about the period 3. Period 3 means that lithium, then we have sodium, then we have magnesium, then we have aluminum, then we have silicon, then we have phosphorus, sulfur, chlorine, and so on. Okay, so as you know that when we go down the group, when we go down the group, when we go across the period, so what about the size? What do you think? What do you think? What about the size? Is it's increasing or decreasing?
Atomic size increases, so it increases. Ionization energy increases across the period.
Atomic size increases, you are saying. Increases.
Doesn't it decrease?
It decreases. It decreases, exactly. It decreases. Atomic size decreases across the period. Remember, when anything increases down the group, so it would be opposite across the period. This is the hint for you guys, okay? When anything increases down the group, so it would be decreasing across the period. It would be decreasing across the period. So let me explain why the size is going to decrease. Let me explain why the size is going to decrease. See this. This is the sodium. I need your attention. This is the sodium. I have 2 electrons in the first shell. Then I have second shell in which I have you can say 8 electrons, in which I have 8 electrons. Let's suppose 1, 2, 3, 4, 5, 6, 7, 8. And then we have one shell in which, third shell in which I have 1 electron. This is the structure for sodium. And then we have magnesium, then we have aluminum. Okay, so in this I have 3 electrons. Okay, this is aluminum and this is magnesium. Okay, as you know that the total number of shells are same. 3 shells, 3 shells, 3 shells. So most of the students think that when the number of shells are same, so the size should be the same. When the number of shells are same, so the size should be the same. But this is not so. This is not so. Why? Because I can say that the shielding is also the same. Shielding effect is the same for all. Like I can say that the shielding remains same. I can say that the shielding remains same. The shielding remains same. Okay. When the shielding remains same, so the outer electrons are going to increase. For the simplicity, I'm going to remove these inner shells. For the simplicity, I'm going to remove these inner shells and I'm going to write down the number of protons in the nucleus. It has 11 protons, 12 protons, 13 protons. Okay, so what is the ratio between electron and proton? 11 is to 1, 12 is to 2, 13 is to 3. So when the ratio between electron and proton increases, so the attraction increases. Okay, so the attraction increases. When attraction increases, so they are coming towards the nucleus. So they are coming towards the nucleus. When they are coming towards the nucleus, as a result of this, atomic size is going to increase. Atomic size is going to increase. Okay, that's it. That's it. That's it. Atomic size is going to increase. That's it. Are you getting my point? How the size is going to decrease across the period? Yes or no?
Sir,
Iman
I did
Amir?
not.
No? Okay.
No.
Okay. So I am saying that across the period, if we are going across the period like left to right, so the total number of shells remains same. It seems like that the size should be like the size remains same. It seems like that the size remains same as the number of shells are not going to increase or decrease. It remains the same. 3 shells, 3 shells, 3 shells. After the aluminum, you would be drawing silicon, then phosphorus, then sulfur, then chlorine, then argon. All are having three shells. Why? Because they are in the same period. But the thing is that when the number of shells are remain same, okay, when the number of shell remains same, but you can say that the shielding remains same. You know, size is depending on shielding as well. When the shielding is same, so then again I'm thinking that the size should be the same because the shielding is same, because the inner electrons are same. All are having two inner electron, two inner shells. When the inner shells are same, this is the reason the shielding are same. When the shielding is same, so the size is same. But due to the increase in outer electrons, sodium has one outer electron, magnesium has two outer electrons, aluminum has three outer electrons. As you know that in the nucleus of sodium you have 11 protons, in the nucleus of magnesium you have 12 protons, in the nucleus of aluminum you have 13 protons. So let's suppose 13 proton and 11 proton. It's just like a small magnet and a big magnet. This is a small magnet, this is large magnet. Obviously the large magnet is having a stronger attraction. So due to this more number of protons, it has a stronger attraction. This nucleus is pulling electrons towards itself. You will see that the size would be pinch, just like a ball. Let's suppose you have a rubber ball in your hand and you are going to just pinch the ball. Just like that, the size is going to be pinched due to the greater attraction between the nucleus and outer electron. When the number of outer electron and when the number of proton in the nucleus increases, so due to the increase in number of proton and an electron, so the attraction is going to increase. When the attraction is going to increase, so I can say that due to the increase in attraction, so the electron would be coming closer to the nucleus. Ultimately I would say that the size is going to decrease. Are you getting my point? Yes or no?
Yes, sir. Now I got it.
Okay. Because when we have a comparison between the lithium and sodium, so you will see a big difference down the group. In the lithium we have 2 shells, in sodium we have 3 shells, in potassium we have 4 shells, in rubidium we have 5 shells, in cesium we have 6 shells, in francium we have 7 shells. So it's very clear, when the number of shell increases, so the size increases. But problem is across the period, because the number of shell is not going to change across the period. So then you have to think in a different manner. So when the number of shells are same, so ultimately then you would be go over the outer electron. So outer electron would be increasing. When outer electron would be increasing, ultimately the attraction between the nucleus and outer electron would be increasing. Due to this, you can say that the size is going to decrease. And remember, when the size is going to decrease, so the ionization energy is going to increase. So as I told you, down the group, the ionization energy was decreasing. But across the period, the ionization energy is going to increase. Okay. As I told you that this electron is far away from the nucleus, it has a lower attraction. Towards the nucleus. It can be removed very easily after the, you can say, when you are going to provide a little amount of energy, so this electron would be removed easily, because this electron is loosely attracted towards the nucleus. If you ask why, sir, I would say that because it's far away from the nucleus. Remember, when the distance between the nucleus and outer electron increases, so the attraction decreases. When the attraction decreases, so ultimately I would say that it would be easier to remove electron. But what's happening over here? The attraction is going to increase. attraction is going to increase due to the decrease in size. This is the reason ionization energy is going to increase. Okay,